In this video, you will learn how to find the volume of the solid of a revolution generated by revolving a plane region that is not adjacent to the axis of revolution. The washer method works by imagining the solid as being made up of many thin washers, each of which is a disk with a hole in the center. The volume of each washer can be calculated using the formula for the volume of the disk, and the total volume of the solid is then the sum of the volumes of all the washers. If a rectangular plane, not adjacent just like shown in this picture, is revolved about the axis, then the result will be a washer, shown like this one. And the volume of this washer will be pi times the r, which is the outer radius square, times the width of this disk W, minus pi times r square, where lowercase r square, which is the inner radius, and time W. And then you can see you can factor W, you can factor pi, and you have left the formula like pi times uppercase r square minus lowercase r square times W. What is washer method? Well, it's a region bounded by an outer radius. So this is your region, and this is R of x. As a matter of fact, this from this line, this is R of x. That's the uppercase R, and that's the outer radius. And this lowercase r of x is the inner radius. And if this is revolved about the horizontal axis, then you have to use this formula. V is equal to pi times A from B. Say A is this boundary and B is missing, so B should be here. R of x squared minus lowercase r of x squared dx. Okay, number 2. Now another plane region. Again, instead of revolving about horizontal axis, we're going to revolve about the vertical axis. So in this case, this uppercase ry is the outer boundary and lowercase ry is the lower boundary. So when you revolve this about this line, we'll have a solid with a hole in it, and the volume of this solid will be is equal to this pi times integral from c to d r of y square minus lowercase r of y square dy. Okay, here's some guidelines. If a plane region is given and the axis of revolution is identified, then follow the following steps. Number 1, identify the function that defines the boundaries of the plane. Then draw the rectangle in the plane region perpendicular to the axis of revolution. Set up the definite integral using following guidelines. If the rectangle is perpendicular to the horizontal axis, then use the following formula of solid of revolution. V uppercase V equals to pi times A to B uppercase r of x square minus lowercase r of x square dx, where r of x, the function that defines the outer boundary, and lowercase r of x function is a function that defines the lower or inner boundary of the plane region. If the rectangle is perpendicular to the vertical axis, then use the following formula: volume of solid revolution. V is equal to pi times c integral from c to d uppercase r of y square minus lowercase r of y square dy, where uppercase r of y is the function that defines the outer, meaning farther from the axis of revolution, boundary of plane region, and lowercase r of y is the function that defines the inner or closer to the axis of revolution, boundary of the plane region. And step number 4, evaluate the definite integral. So here is an example. We have to write and evaluate the definite integral that represents the volume of the solid found by revolving the region about the x-axis. So y is equal to 4 minus x square over 4. Okay, so you graph this one, y equal to 2, like this one, y equal to 4 minus x square over 4 on this one, and they are intersecting at this point and this point. So outer radius would be, you draw the rectangle here, and this is the outer radius, and that's the inner radius. So the outer radius looks like r is equal to y with each variable. It depends on whether you draw the rectangle, so we use the whole function. R equal to uppercase R is equal to y plus 4 minus x squared 4. Inner radius is r, and that's horizontal line, so it's going to be fixed too. Next thing, we're going to find the boundaries in the a and b value. Since this boundary crosses with this one at this point and this one, so we can solve these two equations. So we can solve this equation by setting each equal to each other. So this becomes 2 equals to 4 minus x squared of 4. So we can move around x squared of 4 to the left side, 2 to the right side. And this becomes x squared of 4 equals to 4 minus 2 is 2. And then you cross multiply 4 times, it becomes 8, and it's equal to x squared. Now you take the square root, so x is equal to plus minus the square root of 8. And if you take the square root, it gives you plus minus, 8 is 4 times 2, and square root of 4 is 2, so it becomes plus minus 2 square root of 2. A is the smaller of this value, b is the largest, so a is minus 2 square root of 2, and b is equal to 2 times square root of 2. Wow. What is the axial revolution? Well, that was the x-axis. Since the axial revolution x-axis and the rectangle was perpendicular to the x-axis, so we're going to use this formula. B is equal to pi times a minus b, uppercase r of x squared minus lowercase r of x squared dx, where r of x is the upper boundary, which is 4 minus x squared of 4, and r of x was the lower boundary of the region, that's 2. So we substitute here, and a is negative 2 times square root of 2, and b was 2 times square root of 2. Okay, now it looks like the region was symmetrical about y-axis, and then we can, from calculus 1, we can apply this formula, negative a to positive a f of x dx is equal to 2 times square 0 to a f of x dx. So you can rewrite this and double it to y and remove this one and put a 0 here and keep the 2 square root of 2, and 4 minus x squared over 4 squared minus 2 squared and d squared. Now we square this one, so 4 squared is 16, and the formula says you multiply these two and double it, so 2 times 4 times x squared over 4 plus the square of 2 will be, square of x squared over 4 is x to the 4 over 16, and the square root of 2 is 4. Okay, now we simplify a little, but 2 times 4 is, looks like a 4 cancel, or you will have 2. So then your 16 minus 4 is what? 12. Okay, now we rewrite this one. Now evaluate the integral to find the volume. So we will integrate using the power rule, so it becomes, you write 2 pi, ignore this one, x4 becomes x5 over 16 times 5 minus 2 times x cubed over 3 plus 12x. So you limit from 0 to 2 times square root of 2. So first you put this upper limit. So you rewrite 2 pi, this becomes 2 times square root of 2 to the power 5 over 16 times 5 minus 2 times, that will be 2 times square root of 2 to the power 3 plus 12 times 2 times square root of 2. And that will be 0 to the 5th over 16 times 5 minus 2 times 0 to the power 3 over 3 plus 12 times 0. Let's see, 3, and now we simplify this whole, everything goes to 0. So now you have, again, 2 to the 5th, will be 32, and then square root of 2 to the power 5, minus 2, and then this 2 cube, and 2 cube is like 8, and 8 times 2 is 16. So you're left with cube of square root of 2. And this becomes 12 times 2, 24 square root of 2. Now if you simplify, the square root of 5th root of square root of 2 is a 4th root of square root times square root of 2. This becomes 2 square, which is 4 square root. And this becomes square root of square root of 2, which is 2. And 2 times square root of 2. So the volume V is now 2 pi times 32 times 5th power of square root of 2 over 80 minus 16 times cube of square root of 2 over 3 plus 24 times square root of 2. We can now replace cube of square root of 2 with a 2 times square root of 2, and 5th power of square root of 2 we can replace 4 times square root of 2. So we have this one, 2 pi times 32 times 4 times square root of 2 over 80 minus 16 times 2 times square root of 2 over 3 plus 24 times square root of 2. Okay, now it's simply 32 times 4 is 128 square root of 2 over 80, 16 times 2, 32 times square root of 2 over 3 and plus 24 times square root of 2. We can simplify these two. We divide by 16, we get the 8, and here we get 5. And this stays as it is. Now they have find the LCD, which is 15. So here we multiply 3 on the top, 3 on the bottom. Here we multiply 5 on the top, 5 on the bottom. Here we multiply 15 on the top and 15 on the bottom. So you have a 3 times 8, the square root of 2 over 3 times 5 minus 5 times 32 square root of 2 over 5 times 3 plus 15 times 24 times square root of 2 over 15. Now we can simplify. 3 times 24 square root of 2 over 15. This is 5 times 30 to 160 square root of 2 over 15 plus 15 times 24 360 times square root of 2 over 15. Same denominator. Write the denominator once and write the numerator. 24 times square root of 2 minus 160 times square root of 2 plus 360 times square root of 2. Now it looks like radicals, so we can combine. 360 minus 160 is 200, 200 plus 24 is 224. Now we can multiply with a 2 pi and get 448 times square root of 2 over 15 pi. You try this, putting this answer on the WebAssign. If it takes, good. If it doesn't take, then you put on the calculator and calculate as 132.69.